Okay, so let me extend an official welcome again. Ladies and gentlemen, thank you for coming to the Security Threat Analysis using OMS, Operations Management Suite. Is this OMS acronym sticking with you guys? Yeah? Actually, Tigran, get the video camera up here.
Oh.
And I want to record the actual
You're challenging me with
response.
stuff, man. My camera is here.
Use my phone.
Okay, let me do that.
Yeah. And all right, so let's do. Why are you filming me? Who cares
Just
about me?
say what you want to say, and then
All right.
I'll show.
Oh, actually, I should talk about this. So I'm going to test with the crowd to see to see how much they like the OMS acronym. Okay.
Perfect.
So if you like the OMS acronym, raise your hand. Wow.
Wow.
That's awesome. That's great. They put down their hands so quickly. I don't think you got this side of the room.
I got 360,
Yeah?
and not the back though.
You're slow, dude. Get out of here. You're still recording this. I got to edit that part out. Okay, all right. That's great. Anyway, I was telling my esteemed marketing colleagues that they're idiots, but looks like they're actually pretty smart. You like it. So how many people here actually attended the last session, log analytics using OMS? Okay, so quite a few just came here just to listen to security. All right. Mark here just came here to listen to security. He was one of our head engineer because he got nothing better to do. I was telling the crowd earlier that they want the feature faster and you shouldn't sleep. Right. And so I'm going to take the time to explain the context of how we got to become OMS at this point. So when you sign up for this session, you actually sign up for security threat analysis using Azure Operational Insights. Okay. And for those of you who have actually been following the product since its beginning, and we have quite a group of Genesis crowd, when I was in my earlier session, that started using the tool back in the advisor days. We have, just 3 name change in under a year and a half, which is, my explanation was that it reflects our cloud cadence. And it just, shows that this is how fast we can deliver feature and value. And to a certain extent is the truth. And, we were just kind of like going at the value delivery in an agile fashion. And the more we interact with you, the more we deliver, the more we learn from you on what you actually need. And so in the last, 9 months, as we were operating operational insights, we really learned that what you want is a unified IT management system with a foundation that can operate insights using log analytics, and at the same time have a foundational tool of automation to allow you to issue command and control against your IT operation. That is the foundation of OMS, to see and to control. And on top of that, we build a variety of solutions, right? Such as recovery or chain tracking. And in this session, we're going to be specifically talking about security and audit. And we have big hopes and big dreams with this particular solution. We hope that it will deliver tremendous value to you. And it is really important through the interaction that we have with you that we learn from that. Okay, and so again, really happy that you're here. Is that an okay explanation of why we got from OI to OMS? Yeah? Okay. You don't want me to talk about that anymore, basically. This is like, dude, just get into the topic. All right. So we want to have a particular focus in this talk, which is what's hot right now, okay? And this particular description of hotness is actually not the, sexy hot, but, just like really hot issue. Like as if you're on a hot pan dancing around in fire type of hot. So which is the issue of data breach. So a lot of our demos today, which is all delivered going to be by two gentlemen, basically by Tigran and Brent, who is among us today, is going to be revolving around the concept of data breach, APT, and lateral movement. And Tigran would come up here later on to explain the context of the demo, but I'm just going to give you an overview idea of how that functions altogether. Oh, actually, before we start, how many of you here would consider yourself like system engineers, IT pro, or administrators? Okay, so mostly system engineers. How many of you are here are actually would consider yourself security analyst? Security analyst. Okay, all right. How many of you are confused? Well, you're so honest. I was expecting there's no hands, Ray, and I was going to tell the joke that, according to a research study, people who don't put up their hand who are confused are actually confused, but that didn't work. You guys are smart. Yeah, good job, Tao, for declaring that you're confused. Now you're not. Very good. Okay. So, the picture I was showing earlier here, which is basically listing out all these companies, it's not that we want to throw them under the bus or something like that. They're on the news. And it's really a big issue among the entire industry, okay? And it's so devastating that basically we have a term for this. It's called assume breach. Assume breach. It means that you should just assume that you have been breached, okay? Anders Winberg, our technical fellow, delivered a great talk on Tuesday. Who have attended Anders' talk on Tuesday on assurance? A few hands, okay. His session was great because I was demoing there, right? Yeah, but that's okay. You're going to see the good stuff again today in even greater details. And so, he was joking that, assume breach doesn't mean that you should just give up and, basically update your resume type of assume breach. There is still a way to battle it, but, you should assume that your network has been penetrated already. So in that world, we're going to talk about, how we can apply analytics, right, to find out and gain visibility as to what's going on so that you can take the proper action, okay? So if you had attended the assurance session, these four things would be familiar to you. We had four demos that were shown in Anders' session there. And this session in specific is going to be talking about detection, forensic, and threat response. Okay, but I'm going to go through kind of what we have to offer from Microsoft across these four areas. So just to sum it up, protect the workload from fabric attack is that if you are an administrator of the fabric layer, right, today there are techniques to get from the host to get into the guest. Now, this is especially problematic if you are a service provider or a hoster, right? How can you extend that trust to your customer that your network, that your operation is not going to impact your customer's business, right? And it's the same way that even if you're in a large enterprise, how can you assure of your other departments and teams that depends on you that your operation is not going to impact their workload and their payload that is running inside the guest. And with the next version of Windows Server that is coming out, we have a concept called shielded VMs, which will guarantee that you cannot go from the host, right, to get into guest. If you have a chance to actually watch that session online in the near future, Dean Wells from our team actually gave a great talk on shielded VMs. That guy is a great presenter. That shielded VM presenting it is so boring, but he made it so interesting. It's a shielded VM for crying out loud. You just can't get in. But he made it so fun. So I was like, hats off to him. But good that is boring, right? Because we want that to be boring. It's secure. And then there's protect the workload. From that angle, in terms of protecting the workload, Anders was talking about the fact that, in the beginning of time, we have given the keys to the administrators. And we have effectively ended the world at that time already, right? And so what are we going to do now that we're in this reality? So we've got to face that reality and understand that administrators have a lot of power in the environment. And so in order to protect the payload from direct attacks, we're introducing the concept of just-in-time administration and just enough administration, so that the people who need to do their job, rather than you having to give them administrative rights, because you need that right to do their job, right? And typically you just want to give them the rights. It was like, I want to be efficient, right? Here's the right, and forever holds the key because you can self-service. It's actually all agile and good until you find out that person might be a bad guy. Sometimes an internal bad guy. Sometimes, he is not careful and lost the key to someone outside. None of those scenarios are good. But having just in time and just enough ensures that right would only live for a set amount of time, and that is not a universal administrative capability, so that he just have enough to do their job through PowerShell. And so we're moving into detection. And in the detection pillar, we have two demos. One was the Advanced Threat Analytics product, which just announced preview at Ignite this week. It's a great tool. It was an acquisition that we made a couple months ago. And it's very specifically designed to handle lateral movement. And the second demo was done by me, which is using OMS to handle forensic scenario, okay? So OMS is a great tool to actually gives you the freedom and ability to explore, follow the trail, and get to reveal more of the attacker's path, especially the unknown patterns. They're changing their attacks every day. Those guys out there are smart, but they're never perfect. Okay? Having a system that can capture a large amount of data can help you battle their movement inside your network, assuming that they have breached your environment already. Okay? So that is going to be the focus of our talk. Who in here is really familiar with the concept of advanced persistent threat? Yeah, those same security analysts' hands. Wait a second, is there one that did not raise his hand? No, just kidding. Okay, so advanced persistent threat. Looks like the bigger room here doesn't know what that is. After you hear this, it's going to be really scary. Okay, so, but that's okay because we got the tool to help them. So that's all right. All right, so here's how advanced persistent threat works. You got good stuff in your enterprise. I don't know what you got in there, credit cards, people's social security numbers, all kinds of good data in there, right? If you're a military defense contractors type of, company, you got design knowledge that, perhaps foreign government wants, okay? And these guys are really organized. This is not like some script kiddies trying to hack into your system and, just to make a fool out of you. These are people who have project teams, who's tracking your network, the overall movement inside your enterprise, right? Working really hard, really structurally, really organized to get to the data that they want, okay? And so every organization has one of those stuff in there. We call them high-value assets. Now, typically, you protect this stuff pretty well, okay? You're not going to throw them out, outside of your firewall and, give it a password that is called password, something like that, right? You're going to restrict rights to those assets. So, you guys are smart. You want to hold that, at the depth, right in the center of your network, right? Protecting it. However, you got colleagues, okay? I'm sure everyone in here are smart. You guys are smart people. But then, you got accountants. You have marketing guys, right? It's like, my marketing team is actually, my marketing people are actually pretty smart, but, anyway, we'll go with the flow. Marketing people. Actually, you've got salespeople too, right? Actually, our salespeople is smarter than the marketing people. Sorry, marketing people. Yeah, and they don't do weird stuff on there, but sometimes they just want to save some money on getting coupons, to buy grocery, and because we give all the money to like great engineers like Mark over here, and we don't leave much for other people, and so we need to get like coupons and stuff. And I surf the web sometimes. And, find that, there's good coupons and, click here and save 50%, next time when you buy broccolis, right? And, I fall for it, right? It's like, hey, 50% of broccolis. And so, you download whatever it is on there, installed it, and you establish a backdoor, right, on your laptop, right, on your PCs, okay? And sometimes, they get in through the perimeters, right? The perimeters network are, places where you test your apps, you share your password, you have that one password for the same 20 years, and, you basically pass it on from one generation of employees to another, right? Make sure you don't change this password, otherwise it's going to cause chaos, and make sure you broadcast it carefully so that everyone knows it and they can do their work, right? And so, there's those type of situation, and those stuff sits out in the perimeter, right? And, it's easy to get into those areas, so you can plant the malware on there and establish a persistence. That's why it's called advanced persistent threat. And so they just stay there, all happy and stuff. And now that they're in, they can use a variety of approach to steal credentials on there, okay? And one of which is really popular. You hear all the security guys, they're all cool, and so pass the hash, that sort of stuff. To be honest, I get into the security area because I want to look cool. Because those guys look really cool. You guys out there, security analysts, you guys are cool. Now I'm equally as cool. I'm like talking up here about this stuff, right? And so as people log on to the box, right, after you have established persistence, basically they can take your creds. And once you have taken that creds, you're now basically assume someone's identity, and you're just like roaming through the network with a proper passport, so to speak, okay? You're legit. You're not attacking. There's nothing illegitimate about what you're doing in the network, right? You stole my credential, and now you're Joe Chan in Microsoft. And you're accessing stuff as if you're Joe Chan, right? You're not brute forcing anything. You're not causing any DOS or any weird stuff. There's nothing weird. So there's normal activities on the network. But not quite, okay? Because if you want to get to the high-value assets, you may not be getting the person that you want that have direct access to that asset. Access to that asset. Good job, Joe, for pronouncing that okay. All right. And so what they need to do is take your credential and scan around the network to see who else is there, which box to jump to, right? And I can't access all of the box, right? So for example, Joe Chan doesn't have access to Satya Nadella's inbox. Okay? I don't have my CEO's inbox. But I know people, I've got friends at Microsoft, right? And so, actually, I don't know, maybe you need to get to Satya's secretary, okay? But somehow, there's a 6 degrees of separation, right? I'm sure, like, if you make 6-hop, you'll get to know the person that, knows our CEO secretary. So you need to make 6-hop to get there. So what they would do is that, I kind of skip over this part. When you have a malware and persistent established, what happens is that those guys would be in there on your box phoning home, okay? And these guys are crafty. They don't like, hey, welcome back, malware. Let me just talk to you, and, how are you doing? How's the weather out in Redmond or something like that, right? They just keep pinging, and they have a reserve of all this stuff out there waiting to activate them, okay, when it's time to start the project. Let's rotate the project in here. We got malware all over the place. This week, we're going to start with, Enterprise A. All right, team, let's get together. Have you have your coffee yet? Okay, start the attack. So that's how they roll. So they have a command and control center, and this thing is sophisticated. They basically have a cluster of this stuff out there so that it will receive instructions in a very random and non-deterministic manner so that it's hard to trace. And so once they receive the instruction to do work, then the next thing that they have to do is they have to steal some creds, and they have to do network enumeration. Okay, so they have to scan the network to see what's out there. They look for stuff like, what is the security group? So they will scan things like AD, for example, to make really large LDAP queries out there that, a normal person wouldn't typically do. Like, why would Joseph Chan go out and scan the entire Active Directory for all the security groups and DL out there? Because I really want to read all of them. I got a really, sad life on Saturday, and I just read security group's name, right? Nobody does that. And so, they can drop hints for us to find out about these abnormal behavior that we can trace and find a trail of who is doing weird stuff in your network. But nonetheless, they have to do that. And once they get some information, then they know where to hop to next, okay? Then they're going to use the creds that they got on that box, right, to hop to the next destination, okay? So, there's an intersection of that, boxes that get closer to what they want and credentials to use to get closer to that. And so, they will execute remote execution and get to another machine, and they just repeat their pattern there. Again, right? Once they land there, patiently, they take the credentials again on that box. Okay, and do another round of network enumeration. See, who is talking to who, right? And very patiently, over weeks, sometimes months of times, to get to, eventually, their target asset. They're really patient, okay? This is not the sort of things in which, a normal IDS tool would catch, right? They're not, attacking you. They're just slowly watching in there. They got your cred, so they can take all their time to do that. And so it's a very unique type of attack. And finally, when they get to the high-value assets, they need to find a way to get that information back to themselves. So typically, they need to perform some kind of exfiltration that happens to get the data out back into their command and control center. And that's usually is the typical cycle of how they perform breach attack. So what does it have to do with this particular session, and why does it relate with OMS? So like I mentioned earlier, OMS, at the heart of it, is our log analytics platform. Okay? We're really, really good at collecting massive amount of machine data at scale, right? And you can use that to collect security pertinent information, activity trails, so that you can have the data to observe, just like they are observing you, and you can observe them back, right, to find out who is roaming your network, okay? And log analytics is actually perfect for this type of scenario. Security pertinent information such as security events, I'm sure you guys know what that beast looks like, right? Very high volume, very verbose. They come in very high velocity, right? Every second they generate hundreds of those, especially when you're on the domain controller, right? But even on my freaking laptop here, it generates a lot of events, depending on your audit policy, right? And the content in there is highly varied. The payload is different event to event, okay? And so if you went to my last session, this is exactly what log analytics do really well on. And so we thought that this is a great technology to be applied to this problem, okay? At the heart of it, what are we really delivering with log analytics? I can sum it up with one sentence, which is to tell you who did what, when, and where. It's just that simple. At the heart of it, that's all we're trying to do. Now, who in the room here, since you're all of you guys are system engineers, use the audit collection service from System Center? All right. Great. Well, I'm your PM all these years. I'm sorry for doing nothing about it. At least I didn't put it on someone else. I took responsibility. Every year I come out to Tech Ed and I let you slap me left and right. The Nelly Grandini asked me, I've known him for like almost a decade right now, and he just screams at me every year. I took the abuse. It's fine, right? But finally this year, we finally did something about it because we replaced ACS with the security and audit solutions, and now finally we can let you forward the data to a big data repository without doing like basically rocket science on planning and sizing that ACS collector. And once you got the data in, you can actually query it. Yay, that's right. This is a really honest session. You guys just all admitted that you're not querying that data out. Sorry. All right, so what does that have to do with ACS? Well, audit and compliance is all about who did when, where, and how. The internal auditors or external auditors have different controls in which they need to assess if your enterprise is under control, right? And so you've got to demonstrate to them basically that you have a trail, an audit trail of what is happening in your environment. And you can answer basically those questions with the same technique and technology. And so basically you kill two birds with one stone. Isn't this awesome? All right. So I'm going to roll into demo now. Basically, we're going to start again and refresh your mind on where you need to go. So between the last session and now, how many people have actually signed up for an OMS account? Whoa, you guys are awesome. Should have taken a picture of that. Okay, so this is being recorded. So team, back in Redmond, if you're watching this, we got like a lot of hands that was raised. And you need to thank me for that. Because I worked hard in the last session, and you can see the recording on that over there too, by the way, how hard I worked. So kudos to me. Now, for those of you who have not done it yet, it's just a single click, try for free. I'm not even charging you anything for it. It doesn't expire. The account, you can use it forever. It's a great deal. It's really simple. I promise you, it's just 3 clicks. Okay? And so it's really easy. Try it. And this is the URL, microsoft.com/OMS. Anyone can remember this. Really, I tested on myself. And it works for me. Anyone can remember it. Okay. So with that, I'm going to bring Tigran on stage and show you some good stuff.
Thank you, Joe. Hi, everyone. My name is Tigran Shabazian, and I'm a program manager for security and audit solution in OMS. And today I'm going to do a few demos to demonstrate how this tool helps you, in particular IT pros, because I know in our IT pros, you guys like really managing your IT environment, but you don't have deep knowledge in security domain, and you don't have security domain expertise where like security analysts have advantage there.
Are you insulting them, Tigran?
No. I'm just but this information is really came from you guys. When we did we reach out to a lot of customers, and we constantly doing it. We kind of gathering your feedback. In fact, there's a white paper that you are sitting, some of you own it. Is basically this is the channels, and there are other multiple channels where we're gathering data from you to understand what are your problems, and then. Based on that, we learned that you guys really need some help. And
I don't think that, really saved anything. Don't worry about it. When he goes back, I'm going to ding him for that. Yeah.
Let me log in to my account. So,
screen 8. Sorry, hold on.
For those who onboarded already on OMS, you guys familiar with this screen. But if you guys not yet onboarded, as Joe said, please do it between this session and next your session. Now,
you don't have to listen to Tigran, right? Just like last session. You don't have to listen to me. Signing up is more important. Do it now. Okay? This thing is recorded anyway. You never had to came out in the first place. But signing up, that is unique. Imagine signing up for the product here at Ignite. You can't replace that experience.
So for enabling security and audit, so literally, once you onboard it and you have this screen, you can go ahead and in Solution Gallery, just select one of the solutions, one of the multiple solutions we have, which is security and audit. And please don't forget that, because by default, it's not enabled. And when you select that, all your security artifact will start flowing from all your computers already onboarded on OMS into to OMS server.
Oh, wait a second. Can you go back to the gallery there?
Definitely.
Yeah. So it looks like you got some information. Can you select this thing right here? I mean, secure and audit.
Correct.
You have some information on the side right here. What are those?
So basically, we're describing what kind of, what can do this solution for you and how to configure initially like that. But right now, what happens, with one single click, you onboard that. But you're in full control. You can control how much data from all your environment can flow to the cloud. So in fact, that your GPO policy can control level of audit information you will be capturing on the machine, as well as same data will be flowing to the cloud. Now, in terms of...
I think they know that already, so you didn't add any value there.
Okay.
Right,
then it's that simple. That's even better, right? Okay. So I'm going to go back to overview screen, and one of the solutions, as I said, is security and audit. Once you enable it, will appear here. And within few minutes, you will start getting data from all machines. And the machines can be hosted on on-premise or on any cloud. As a similar, for example, Azure, AWS, or any hoster like other hoster like Rackspace. So it doesn't matter. And also, recently, previously we worked only on Microsoft-centric OS, right? We extended recently, and now we started supporting Linux, and it will be richer and richer experience for with time on Linux machines as well. So with that, let me go ahead and deep dive into security and audit solution. So what you see in front of you right now, this is a view that by default we pre-canned for you. And the first set of, first column, it's a security posture view, which helps you to quickly assess your state of your environment from security perspective. In fact, here, it's quickly giving you summary of how many active computers you have in the system, that we are basically deriving this information from your security artifacts, such as firewall logs, Windows security events, enriched uploader events, and etc. Now, in addition to that, there's multiple things that you can see quickly, but one of the things I noticed here that there's one account in my environment has been changed. So this is view where you can quickly identify some anomalies because it's giving you change and then the trend, whether it's going up or down. And here I see there is a change. And each tile here is drill downable. If I will click on that,
one account. Why are you drilling down into that? So
I'll tell you what. Because I manage this environment, basically this demo environment, and I know I didn't enable any accounts. I would like to know, is someone playing in my account that I don't know of? Especially in APT, there's a lot of cases that people stealing the credentials and identity, and they acting on other people's behalf, as you mentioned. So what I see here is guest account. And guest account, you guys know by best practices, nobody should enable in domain especially, right? So I see that guest account went through some changes. So
you're a douche for enabling it.
So let me figure it out. Who did it, right? So Joe, surprise. So it looks like someone enabled it, and this is Joe Chan. It's your account. So, so this is like one of the cases.
That's not the same Joe Chan.
Maybe, because one of the things I noticed here that let's figure out if someone enabled, if there's any logon with this account. So let me remove the query that behind the scenes, like as you noticed, anything I'm clicking, there's a search query that automatically being generated. And then this gives you ability to basically with mouse clicks do different interaction. But if you get like some advanced, not really advanced, we have a cool feature that our engineers that not sleeping and working on this enabled, like auto suggestion, will help you to teach language syntax that we prepared for you as well. So now what I changed the syntax here, and I'm running the query asking, give me all security information about guest, whatever contained guest information. So what I see, there is a lot of information dumped here, but I have a useful view here where I can scan, which is aggregating by default fields. And one of the fields I see is guest account in some Beacon M02. Bacon, okay. Oh, I forgot. It's a food. Our servers, everything is like named after food. We have like waffles, noodles. So this one is bacon. Okay, so if I will click on that, actually what I would like to know, is there any logon by this particular account? And luckily, what I see, there's 9 events, and if I see that the activity says that all 9s account failed to log on. Looks like someone has enabled that, but never logged in successfully. So of course, the mitigation step will go and disable it back and figure out which Joe Chen did it if it's not you.
You need to get to the bottom of that.
Yeah, definitely. So with that, let me go back to this screen. And what we learned from all customer studies, we figured out that most of you guys, you like a lot of dashboards, views and all this, but sometimes you don't know where to start. You don't know, is there anything weird going on in the network that will have to trigger you to do any investigation? Because every morning you go, you see different numbers. Okay, numbers doesn't mean anything, right? Like sometimes. So what we did in that area, we worked with our security experts at Microsoft, and we took expertise from them and some intelligence, and we transferred that into the tool in form of search queries. And we created a view called Notable Issues that helps you to pay attention on something that anomalies going on in your network, or something that will trigger you some investigation. So basically, in ideal world, but we know we're not living in ideal world, it's supposed to be 0.
Right, yeah.
But if it's like more than 0, so you better check it out.
And originally, I wanted to name this blade called Nasty Stuff, but Tigran said that Notable Issues is a little bit more appropriate. But if you look at it, it's pretty nasty stuff on there.
So to demonstrate one of the APT scenario, what I did, I asked my good friend, Yuri from Russia, he's like ethical hacker, to perform some attack. And I didn't tell you that before, but on the environment, on 21 machines that I monitored. And I said, don't tell me what you did, and I will try to understand whether I can find out what's going on. So he did something, and then because the guy saw my slides and Joseph's slides, explanation about APT, I said most likely this guy will start with some executables. And you may see here, one of the notable issue categories says suspicious executables. And this is where I started also, obviously. So I clicked on that to see what are the suspicious executable I have in my network. And this view gave me list of all file hashes that our algorithm found to be suspicious. And I'll tell you something about this. This is detection of suspicious executable, even in most of the cases, will be much earlier than any malware can detect. If you look on the industry right now, like it's not in industry, like hackers keep changing their malware. And then for malware, anti-malware, it's very difficult to keep track of new malware that's coming out. And in fact, some malware, they're releasing their code to be open source, so people can recompile and then with new hash try to deploy in the system. And this is finding those, and it applies simple rules. It's trying to find some rare occurrence of unsigned executables in the network. And turns out what we learned about big percentage of those occurrences turns out to be a malware.
We find signed ones too, right? If they're running really rarely as well.
Actually, this particular rule going after unsigned.
Going for unsigned, okay.
Yeah, because when it's signed, it's the company is behind that. They signing with and in signature, usually name of the company appears and all this. But the list of rules right now, we pre-canned rules, and what we are planning to do, we'll keep it up to date, and we will add more and more. And so in this way, if you're onboarding on this service, so you'll get latest and greatest.
It's just search queries, right? Super easy to ship.
It's super easy, definitely. But sometimes, and actually it's applicable to me, I didn't know how to start my investigation earlier until I start talking with our security analyst and learn some expertise. But once we learned, we kind of like stolen that data, and it's here. And we're sharing with you guys now. So, okay, let's go ahead and continue that. So there's one file hash. On top of it, I click on that to learn what is the executable behind that. So I see there's a process named PDF editor free.exe. Looks some freeware someone downloaded. Or I don't know like how they, right now in my demo, I'm not investigating how it got to the machine. So I'll try to understand what the impact of this. So what I see, luckily, it's running on one single computer, which is Bacon M02. Now, the next step for me is to learn what else I know about that executable. I clicked on that, and my query added, I'm adding, actually removing statements that tell some logic behind that we came up with to learn everything that I know about this executable. So when I execute this query, actually I'll find out when this process exactly has been executed, when it's terminated, and in fact that each record here is from security artifacts. One of the things I would like to learn after that, let's say, I would like, is anytime when there is a malware, either malware itself making some evil activity, or it's spinning off some other processes and doing that by using other. So in this case, I would like to learn if there are any other processes spun by this process. So for that, I'm going to open this file creation event, new process has been created, and look at the process IDs, and find out all children process for this executable. So I can type in and continue typing in the search, or interact with data. But luckily, we have here a safe search that makes my life easier. So I prepared some search queries to make it faster. So one of the query I prepared is child processes, where when I execute that, it will give me all child processes of that particular executable, because process ID I took from that the process creation event.
Now, pretty easy to type. Can't type?
I'm so lazy. I'm sorry. So what you see here, actually, one of the processes is psexec. For those who are familiar with psexec, it's a lightweight telnet replacement tool.
Everyone knows what psexec is? Yeah.
Oh, perfect.
Okay. All right.
So if psexec in the good hands, it can create magic. But in my case, there's some suspicious executable that's spinning off psexec. Let me figure it out what exactly happening behind the scenes. Especially, I know, I didn't know what psexec was like few months ago. But once I learned, I said, like, definitely there's a telnet-like communication. There should be another side that this process creating communication. So at this point, because my time interval is basically see that this is when it happened, I would like to know during that time interval which computer has been contacted by a PSExec. So I created another query because I'm lazy. I could type it in too, right? And what I see is this query finds which computer has been contacted by PSExec. So initially, we found the beacon M02. Now, this query returned me beacon M04. So it looks like the communication from one computer has been established to another computer. So the next thing I would like to know, look, okay, there's a communication. What happens on that remote box? So one of the things I can do, I can click on this name of the computer, remove everything that I just automatically added, and learn about it. But I'm not going to do this way because it's like giving me all processes running on that computer. Now I would like to scope down to the processes that has been established, initiated by remote session, which is like basically will narrow down to the processes that has been executed by PSExec. And because I'm lazy, I created that
I think they
session.
get that point already.
Yeah, I think I would like to stress that. So what I see here, there's a 3 executables has been run by that remote session. And if you look at this query, there is 2 different queries that I actually, in statement is pretty fresh. We recently released that, and not released it, actually preview mode. Oh no, it's released.
No, it's released.
Yeah, it's
I
production.
just announced it like 2 hours ago.
Yeah, then no, it's not secret anymore.
Using the word recent is right. Yeah.
Perfect. So this allows us to do different queries, like, and basically do kind of join in between them. So what I see here, one of the processes is FTP client. So it means that not only that it's establishing communication, there's an FTP running, and then it's doing something. I would like to immediately understand where it's sending data. So another search query, getting like every communication from firewall logs. Right now we pivoted to another type of data completely, which is also available in OMS. And this is giving me list of 99 IP addresses that has been communicated. But I see like there's a bunch of similar IP addresses that a lot of data is being sent to that. So right now I'll conclude that looks like there was a small lateral movement, which I'll explain in a bit what I just uncovered.
You want to conclude? Let me conclude for you. You're screwed.
Yes, that's right. But I know who did it, so that Yuri guy needs to.
Are you sure, Yuri?
Yeah, man.
I heard he was sick.
So what I did after that, once I uncovered it, I created this slide and put together what I learned from the tool. And actually, I presented back to him. I said, like, is this what you did? And he was amazed that how come I uncovered, because he thought that I will go with an event viewer and try to find out what he's going to do. So basically what happened is beacon M02 got some suspicious executable. It's created a spun off the child process, which one of them was PSExec. We found another computer that has been contacted by PSExec, and on the remote session, it executed few executables, but one of them was FTP. And we used firewall logs to identify where it's sending data. Now, what he corrected me, I put one IP address, but in reality, it was multiple IP address, and he told me he is FTPing to the cluster of things. So, good. This is like one example. Now, but we also mentioned that about ad hoc analysis. Like, another scenario can be you coming early in the morning, you're reading something on the news, and this is like, it's not a new tool that recently I saw on the news again, the Mimikatz tool that tells you that it cannot be found by antivirus, but it's tools that people are using to steal the passwords from memory. So I did a simple thing. I just myself executed that. It looks like I stolen your password too, Joe.
Oh,
so
thanks.
Just, you have to
Good to know.
it. So what?
Make sure you give yourself a promo.
That was dangerous. I had to keep to myself, by the way. So one of the things I would like to show right now is to do like ad hoc investigation. I'll go to log search here, and I will type in Mimikatz, the name of that tool. And I will search. So what it will do, it will search across all the data types that we have, and it will give me all instances that contain that name. So one of the things I can quickly see here, so I found where it's run, because I executed that in this particular case to create a demo environment. So, and I would like to show you how, if that was you and you find some instance like that, how you can find out what are accounts that has been affected. I did a click on the name of the computer, and now if I'm removing this, actually, you know what? I'll do like safe searches. How about that?
Sure, you've been doing that all along.
You see why I'm lazy? Because I cannot even type it correctly. So when I found this computer, that Mimikatz was there, and I just want to search to learn what else happening on that computer. Now, when it returns me results, the result will include everything that I learned about that computer. All processes, if I will, actually, this is the interesting part. Now I know everything, not only security events, but also configuration changes and all this that I can select and then drill down for on one particular thing. But now, what I would like to do is to do the following. When something happens like that, I learned what that tool does. It goes and in the memory steals the Kerberos ticket, and whoever logged in since last reboot, I can steal all passwords, and then once I steal, not password, tickets, and I can use those tickets to impersonate. And in fact, that I just want to tell Joe that I use that tool to log into the domain controller and enable the guest. Just so you know. So what I'm going to do, I would like to find all reboots. So I have a search query. I will run that, and then search query will tell me when reboots happened. And now,
so basically, you read in the article that if you install Mimikatz onto a particular machine, right, after reboot, then it can start stealing creds.
No, from the last reboot, whoever logged in, I can. All tickets are in the memory, and I can still dump them and steal. And if it will be rebooted, then from the memory, Kerberos tickets will be gone. So the fresh new session, if I will run, I will not find anything.
Okay, thank you for explaining that.
So now my query will return when it was rebooted. Looks like this machine is keep rebooting all the time. So let me minimize the time interval and say, at this point, I would like to find all potentially compromised accounts who logged into that particular machine, because it's fried egg 02. And I will click on that saved query, which is extremely I could have typed in. And this will return 15 accounts that, and now I'm telling you the truth, I stolen all Kerberos tickets for those 15 accounts. And now, but if it's IT Pro, so you can uncover this and say, okay, now I know what accounts potentially are compromised, and I can do mitigation steps, which will be, of course, kill that Mimikatz instance and make sure that who is doing that punish him. And either let them reset password or set up the two-level authentication. Now, I'll go back and show you a couple more short scenarios. And I'll go back to security and audit and to my favorite notable issue section, and I'll focus on the failed logons. So failed logons can be a simple query, right? And it is simple query. And in most of the cases in our environment, it happens. Everyone, especially I, 3 times typing in, doing typo. On fourth one, I logged in successfully. That's why I love that the sensor, I hope we will have everywhere, not on surfaces, yes, not available. Now, what I would like to show you that I see here a pattern that there's few accounts that has been failed logons in last day, 6 or 7 instances. It's not that scary. But when I see there's 3 administrative accounts that is keep getting failed logon, and I would like to understand, is it something that really user trying to do? But looks not, right? Because looks like every day, every hour, every bar is an hour, he's trying consistently between 6 or 5 instances to try different passwords. So it looks like someone is trying to do find out the password of admin. So this is like simple scenario that I found from there. Now, clear logs is another one that some layman attackers trying to clear logs after them. But they don't know that it's too late. From the moment that event fired, the event already leaving the box, and we capturing it, and we know what exactly is happening on each and every boxes. So, and in fact, if I will click on that, I will see the instance where event has been cleared, and then such fried egg, same server where I run the Mimikatz, I tried to clear evidence after me, but too late. Now, another thing I would like to show you is a contextual view that we brought into security and audit. So any solutions that you enabled, on overview you have a representation in the tile. But once you're in security and audit, sometimes you need security-related context, like to understand why threat happens somewhere, or you know that there's some cases that there's an anti-malware can detect something, and maybe by the time it's like doing quarantine, it still spins something evil, and you would like to investigate what else happened there. So we bring that into this drill-down view by exposing the relevant search queries here. And this search query will give you visibility into how many threat has been detected by anti-malware solutions that you imported. Also, servers that missing security patches or security or regular critical patches, etc., etc. So, of course, you can go from there. It directly will give you the details. But I would like to show you right now another query that I created that involved IIS logs. So let me go to my search. IIS logs is recently we enabled that now with one single click you can enable IIS servers to send IIS logs to OMS. Okay. So I created a query that tells me computers with 404 errors, and all those 404 errors, all those 404 errors is coming from IIS logs, and it returns me 2 computers there. And one of the computers I see big spike, a lot of 404 errors. And next thing I would like to do is to find out which page is giving me. Is that one page that maybe home page is down, but maybe it's not. And my query, I saved it, will give me all pages that giving me 404 errors. In fact, that I see that there's 996 pages, but this web server has only 100 pages like altogether, and some small script that I generate few pages. I definitely know what it is. So it looks like that someone is trying to match different path URLs to see whether it exists. I don't know what the reason is. And my next question will be, give me all IP addresses who is trying to do that. I'm trying to figure out where it's coming from. And my next query will return me that, and I will see that majority of that coming from this particular IP. So this is like another example of how you use different security artifacts to come up with some of the investigations. And last thing I would like to show you is a dashboard where you can pin your saved searches, like whatever your favorite searches. In fact, that I created list of my, I will call it laziness searches. So I can go to dashboard and configure it in such a way that my favorite searches, let's say there's a 404 error that I just did, servers with 404 error, I can drag it here and see it every time on my dashboard. And I have ability to configure it differently in such a way that instead of like listing all servers, it will give me only number of servers, because I expect my servers to be 0 404s. I would like to keep my quality of service high. And I can set up threshold as well. And those are basically some of the investigations.
Thank you, Tigran.
Yeah. Thank you.
Great job. Thank you. That's the mic. So thank you, Tigran. I hope you can see that based on the conceptual concepts that we've shown you in the previous session, how it can be applied to the area of security. As you can see, simple, intuitive experience coupled with big data can help you do a lot and reveal a lot of insights. Now, I'm going to bring Brent up here. Brent is a Brent, what's your title in ExtraHop again?
Manager of Technical Marketing Engineering.
Okay, I don't think I'm going to remember that.
I'm an engineer.
But, engineer, I can do that. Thank you, Brent. So Brent is a engineer from ExtraHop. And ExtraHop is one of the partners that we've been working with in the last a couple of months to get their solution onboarded to OMS. And Brent, why don't you spend some time to explain who ExtraHop is and how you can help in this scenario?
Sure.
Okay, take it away.
So ExtraHop is the leader in wire data analytics. What I mean by that is we sit passively on your network. We accept and look at all the traffic going across the wire. And then we reassemble that together into the flows of data going across the network, and then extract value from that and take actions on that. I'm going to show you that being surfaced through the OMS suite, but we also have our own UI that you can use to look through that data. We're flexible and extensible. I'm going to show you just an example of how we're flexible and extensible. Mentioned before, we're passive, so there's no agents installed. This is strictly acting on packet data copied off to us. So we're not in line of the traffic. We're not actually in the packet path. We're just getting a copy of it. A lot more to talk about on this. So I would encourage you to stop by our booth. I'll give you a demo later on, or meet with me after the session. We can give you some information about that. And here's a quick screenshot of just one of our dashboards. Again, not going to be using this one for this demo, but I could show you this later on. Actually, we're on 5 right now. 8. So give me a second to pull up my dashboard here. Hopefully we're not looking at a blank screen the whole time. Okay, so here's some examples of some operational dashboards that I've put together. While this one loads up, what we're going to want to be looking at are these two over here that are showing us 2 key pieces of information that I'm extracting off the wire and then sending to OMS. First is we're detecting if there's port scans happening inside of a network. That number should basically always be 0 because we don't expect that to be happening on a corporate network. And 2, if we're seeing database login failures, particularly from hosts that shouldn't even be database clients, that's something to take a look at. So these numbers are not 0, so we want to drill in here and figure out what's going on. So I'm going to start with the port scans because that jumps out at me as something that we just shouldn't be seeing. So I've got a saved query that's going to run here, and we're going to see where all those port scans are coming from. We can see on the source location here that all of the records that we're looking at are all coming from one IP address. So we're going to see this IP repeated a couple times throughout here. And we're seeing that the number of peers that this device is talking to, it's quite high. It's talking to hundreds of IPs at a time, trying to walk down through the network looking for something. So the question then is, well, what all is this IP address doing? So let's add that to our filter. And then filter it down so that we're just looking at what that IP address is doing. So I'm simplifying what my query is here. And we're looking for just that one IP address, what all it's doing now. And we can see some events here. One is the SYN scan detect I was just looking at, but we can see other stuff too, like this extra hop DB login here. That actually represents login failures. That's what I was showing you on that previous graph. There's database transactions coming from this host, and we can see doing some FTP and some other things like that. So let's take a look at the database logins here, because it shouldn't be, this host shouldn't be a database client at all. And if we see it having failures, it's an indication that something's happening. So the first thing that jumps out to me here is we see a whole bunch of database login failures, and it's coming from a variety of different hosts, things like admin, administrator, root. What this represents is a brute force attack. So we saw the port scan happening. What probably happened here is they found a database server they wanted to break into, and now they're focusing on getting into that database server by brute forcing the account. So let's go back a step here and look at what they actually did within the database, because we see database transactions. So we can assume they actually managed to get in there, otherwise they wouldn't be able to run queries. So again, from the stance of us operating on the network, we're seeing network traffic. This isn't an agent. We're not running a database profile or something like that. I can actually show you the raw SQL transactions that were going across the network. And what I want to do here is sort this by the response time to last byte. So we can look at large queries that are going across the network. So let's let that run for a second. And we can see that, look at that. We've got a select star from orders being executed there. Well, I have some knowledge about this database, and I can tell you that's actually a lot of sensitive data. There's information about our customers in there. And we see this user breaking into the database using the extra hop account here and downloading basically everything out of the database. So I'm pretty worried now. This machine shouldn't even be a client. It broke into my network somehow. I'll get to that later. We see it scanning around. We see it breaking into a database, and now it's downloading a whole bunch of data that it really shouldn't have access to. So again, let's peel this off and take a look at some of the other stuff that we see this host doing. FTP seems a little strange. Let's drill in on that. We can see some FTP commands taking place, and they're all going to this one host, this 14.146 address, and we see it in fact pushing out a file. Well, I'm going to assume that that's pushing out my database traffic there to this unknown host out on the internet. So let's pivot now and take it from looking at the host on our intranet to looking at this suspicious host and see what else that host was involved in. Take a look at our event list here. We see our FTP traffic, some SMTP, and some other stuff. Well, it's weird that we're seeing email from this host. Maybe that has something to do with what's going on. So drilling in here, looking at email that was received from that external host, I can see a handful of emails, and they all have a pretty decent-sized payload attached to them. Well, now it's all starting to come together here. I'm suspicious now that email might actually have had something bad in it. Well, we can see an HTTP transaction, once again, to that host from that IP address that we saw internally before, and we can see it connecting to the evil host downloading this malicious payload. So there we've just seen a spear phishing attack. We've seen this email come in from a host that we were kind of worried about. It's got a big payload on it, and now we see it downloading some executable off there that it's going to do something with. The last piece of this that we're going to show is it making an outbound connection That's our TCP open connection here. This is the command and control connection, actually. My queries. Oh, I am. Thank you, Mark. So yeah, we're seeing connections out now to port 22. That's SSH. This is a reverse tunnel being opened up out to that same malicious host. And this is what's used for the command and control connection. So we kind of came full circle around now. We see an email come in, big payload. User downloads that, clicks on the link. They get compromised. We then see a command and control channel open up. Then the user breaks in. And then we start out with what we started out with originally, where we have the port scan leading to the brute force attempt, leading to the database compromise, leading to pushing that out. Again, this was all done via data we've extracted off the wire. Something that I want to comment on too also is, so we showed some of these same steps in Tigran's demo where they were showing similar data via logs and things like that. I don't want to position this as being a replacement for logs and for machine data. This should be viewed as a complement to that. When you combine those together, you can do some really powerful stuff. I kept it separate here, though, just to keep it clear what was coming from wire data and what wasn't. So that's what I've got. I would appreciate you all listening. And if you have any questions, feel free to hit me after the session or stop by your booth.
Where's the booth again?
You know? We're in booth 305.
Booth 305.
Thanks.
Great job, Brent. Thank you. Let's give him a hand again. Great job. And so ExtraHop is a great example of how we want to work with various vendors out in the industry to bring the value, the unique value that they contribute onto the OMS platform so that you get the maximum benefit of your investment in gathering the data into a single big data repository, and we can enrich that with additional context, not just from Microsoft, but contributed from the entire industry. Okay? So I'm going to wrap up here with kind of like a roadmap slide of what we're going to be doing in the next couple of months. So we're going to be adding additional support in terms of different data sources coming into OMS. Syslog, as I mentioned, is an important area that we're going to be investing. Linux in general, we're going to go all into that to give you maximum visibility around that platform. On the Windows side, we also want to start leveraging Windows Event Forwarding, which is actually built into the OS. And so for places where you don't want to enable the agents, for example, client machines, right, where you want to get logs out of that and there's too many of them to start installing agents on, you can use group policy to get that turned on, configured, and get the logs in, right? Now, threat intelligence integration is actually a really interesting area. Microsoft is an important contributor to the security industry. We have a great team of security analysts, probably one of the largest body of security analysts in the world, where we're generating huge amount of security-related intelligence data that we shared with the community, for example, with FBI and different government institutions that helps fight cyber crime out there. So one of the units within Microsoft, for example, was the Digital Crime Unit, where we track and look at different hackers, especially their command and control sites, using legal procedure to actually take down that site, to take control of that, so that the data that is sending to those sites is now then rerouted to a sinkhole, and so it wouldn't get into the wrong hands. But we can also detect that if you got malware running on your system where they're exfiltrating data out to those bad sites, we know about them, and we can inform you about that, and we're going to be bringing those type of data to you through OMS in the next couple of months. Another thing that we'll be doing is more visualization. You see that a lot of the demo today was really centered around the searching aspect of that. And just looking at that thing over time just makes you feel dizzy. So we want to add some color to it, make it a little bit more fun to actually traverse through the network. And so with this knowledge that we have right now, we can actually build more visualization on top of that, so we can use a more graphical approach to investigate and look at the trail that is left behind by potential attackers. And so again, help us prioritize your ask using the feedback tool. And we might be reaching out to you to help through surveys, through phone calls. I hope you'll be receptive to that. And again, if you haven't signed up, you can't give feedback to us. So you've got to sign up. There's all this good stuff out there. Sign up today. Thank you again for your time.